Here we're looking at example 5 from our 4.2 set of notes. We're asked to graph this intercept form parabola. Now, just starting off with the x-intercept, we know that we're just going to go ahead and take the opposites of our values inside of here. So that would come out to be -2, 0. And just again, taking the opposite of this one, comes out to be -8. Y value is always 0 for x-intercepts. So again, graphing these points, we have -2, 0. There he is. -8, 0. There he is. Again, the y values are always 0 because we are crossing our x-axis, so they're not moving up or down any. Now moving over to the vertex, well, just looking for the halfway point between these two guys. Looks to be about -5. So this would probably be our axis of symmetry at -5. To then get where the left side is matching the right side. But just to algebraically prove that, we know that our x value for our vertex comes out to be p plus q. So in this case, -2 plus -8, all divided by 2. Basically trying to figure out what is the average of that p and q. So then it looks like our x value is happening at -2 plus -8 is -10 divided by 2. So in fact, we are seeing that axis of symmetry, or our x values vertex, at -5, just like we were kind of predicting with our line. Now, we still have no idea what our y value is for the vertex. We were able to find the x, but we have no idea what is our y value. So all we have to do is pretty much plug that in. So for the y value, we're going to throw in our x for our vertex. So we know it's -5 that we're going to throw in here. We have y then is equal to negative times -5 plus 2 times -5 plus 8. So then y is equal to -5 plus 2 comes out to be -3. -5 plus 8 comes out to be +3. So negative, really, this is just -1. So -1 times -3 comes out to be +3. Times 3 comes out to be 9. So y should be 9. So then for our vertex, it is, again, the x value is -5. Y value was 9. Going ahead and graphing that, we have -5, +9. So right about there is our vertex. For the axis of symmetry, we've actually already found it. X is literally the x value from the vertex, so -5. And that again is our mirror. Now for the y-intercept, the game is always the same. You're just throwing in 0 for x because you're trying to figure out where is it crossing this y-axis. We don't really know where that's happening, but we at least know that our x values are not moving left or right any for that, and that's why we're throwing in 0 for x. So we have then y, which we don't know, is equal to -0 plus 2 times 0 plus 8. So then y is equal to -0 plus 2 comes out to be 2. 0 plus 8 comes out to be 8. So when we multiply these three items, we end up then with y is equal to -16. So for our y-intercept, it's 0, -16. Now on the graph, we've already kind of graphed these things by ones. So 0, -16 would be pretty much about somewhere down here. So maybe it's about right there. And if we extended this down, because we are 5 units to the right of that mirror, we'd have to go 5 units to the left of that mirror. So then we would see that happening to be at right about here. And it's a little harder to see that reflection just simply because we're off of the graph, but the game is still exactly the same. Now if you think about this, this is your y-intercept. So your x value is 0. Well, to get to that mirror, you'd have to go 5 over to the left. like because we're 5 units to the right of our mirror, we'd have to go 5 units to the left. Well, our axis of symmetry is that x equals -5. And in order to get 5 more over to get that left-sided point, you'd have then your x value being -10. For the y value, it's still -16. So that way they're exactly the same. Going ahead now and connecting all the points, we should end up with something like this. And so yeah, that is more or less what our graph would look like. Again, that is example 5 from our 4.2 set of notes.